Now, simplification of indices. Let's look at this problem. You have 32 exponent negative 3 on 5. So from what we've learned so far, we see that because this thing is having a negative index, when you reciprocate this number here, this negative index should tend to a positive index. So we have 1 over 32 exponent 3 over 5. Now the 1 here will be influenced by the exponent 3 over 5. The same as the 32 will be influenced by the 3 over 5. Now 3 over 5 here can be written as, let's say 3 over 5 can be written as 1 over 5 times 3. So this thing can be written as 1 over 5 times 3. 32 here can be written as 32 1 over 5 times 3. So this 1 exponent 1 over 5 can be written as the fifth root of 1. And this thing here can be written as the fifth root of 32. Now the fifth root of 1 is 1. The fifth root of 32 is 2. 1 raised to the power 3 is 1. 2 raised to the power 3 is 8. So that's it. Now let's look at this case 2. 0.027 exponent negative 1 over 3. Now 0.027 can be written as 27 over, we have 1 2 3, so 1 2 3, which means 1000. So when you reciprocate this, we have 1000 over 27, and this one will tend to positive. The index will tend to positive. So the 1000 here is being influenced by 1 over 3, and the 27 also 1 over 3. Now the 1 over 3 here means that the cube root of 1000. 27 here also means the cube root of 27. So quickly, we can treat this as 10 raised to the power 3, 1 over 3. And this one becomes 3 raised to the power 3, 1 over 3. So this 3 cancels that, this 3 cancels this. So you'll be left with 10 exponent 1 over 3 exponent 1, this one here. So we have 10 over 3 at the end of the day. The same thing here. This one too, you can treat as 2 exponent 5. So when you have 2 exponent 5, the 5 will cancel this 5. You will left with 2 raised to the power 1. And the 1 will multiply the 3, giving you 2 raised to the power 3. So that you can get the 8 here. Now let's look at this. 27 on 64 exponent negative 2 over 3. So because you have a negative index, you just reciprocate. So you have 64, 27. So that this one becomes a positive index. Now the 64 here can be written as 64 2 over 3 and 27 2 over 3. Now 64 can be expressed in terms of 4, 3 times. 27 can be expressed in terms of 3. Now because of the 3 we have here, because 64 can also be expressed in terms of 8. That's 8, 8, 64. But we just want to cancel the 3 here. That's why we are using 4. So this 3 cancels this 3. This 3 cancels this 3. Now you'll be left with 4 exponent 2 and 3 exponent 2. 4 exponent 2 is 16. 3 exponent 2 is 9. You leave it like this. Now let's look at this. We have 16 exponent 5 on 4 multiplying 2 exponent negative 3 multiplying 2 exponent 0. So with this, you can express 16 in terms of 2. So 2 exponent 4, you have 5 over 4. And this becomes 1 over 2 exponent 3. 2 exponent 0 is 1. This 4 cancel this. You will left with 2, 5 times 1 over 2, 3 times 1. So we have 2, 5 over 2, 3. And we have 2 exponent 2, which is equal to 4. Because 2 exponent 5 over 2 exponent 3 is the same as 2, 5 minus 3. And 5 minus 3 is 2. So the answer becomes 2 squared, and 2 squared is 4. Now let's look at this case. 49 exponent 2 over 3 divided by 49 exponent 1 on 6. Now, from the division of indices, if the bases are the same, we subtract the exponents. So we have 49 2 over 3 minus 1 over 6 all over. We have equal base here, 1 over 7 negative 7 over 6. For multiplication, we add the exponent. So we have 49 here, 2 over 3 minus 1 over 6. We get half. And negative 7 over 6 plus 1 over 6. We get negative 1. Now 49 exponent half can be written as 49 can be written as 7 squared. And 1 over 7 exponent negative 1 can be written as 7. Because when you reciprocate this index will change to positive. Now this square cancels this. It will left is 7 exponent 1 over 7 exponent 1. And we have 7 on 7, which is 1, because this will cancel that. So that's the answer. Now the next question we are looking at is 8 whole number 2 on 3 plus 4 whole number. 8 exponent 2 on 3, 4 exponent 3 on 2, 16 exponent 3 on 4. Now 8 can be written as 2 cube. Why are we using 2 cube? Because of this 3. We just want to cancel the 3 there. 4 can be written as 2 squared. 16 here can be written as 2 exponent 4. Now this will cancel that, this cancels that, this cancels that. So we'll be left with 2 squared plus 2 cube all over 2 exponent 3. 2 squared plus 2 cube, we have 4 plus 8 over 8. And what do we have? We have 12 here on 8. So it's the same as 3 over 2, or 1 whole number 1 over 2. Because 4 goes here 3, it goes here 2. Now let's look at this case. We have 27 exponent half, 8 exponent 1 on 3, and 81 exponent 1 on 4. Now this 27 exponent half, we can't write 27 in terms of 2. We can't write 27 in terms of 2. So we just maintain it like that. So we have root of 27 plus 8 exponent 1 on 3 can be written as 2, 3, 1 over 3. 81 exponent 1 on 4 can be written as 3 exponent 4, 1 over 4. Now this 3 can cancel this 4 can cancel that. So we still have root 27 here plus 2 exponent 1 is 2 and 3 exponent 1 is 3. Now root 27 is the same as 9 by 3 plus 2 all over 3. And 9 by 3 is the same as 3 root 3 plus 2 all over 3. Now this thing you see is the same as 3 root 3 all over 3 plus 2 over 3. This cancels that. You will left it with 3 plus 2 over 3. And I think you can end here. Yeah, because that's the best, or that's how far you can go. Now the last example, 8 exponent negative half plus 243 exponent 1 on 5. Now 8 exponent 1 on 2, negative 1 on 2 can be written as 1 over 8 exponent half. And this thing is the same as 243 can be written as 3 exponent 5, 1 over 5. And what we have here is 1 over root of 8. And this 5 cancels that. You'll be left with 3. Now, root of 8 is the same as 1 over 4 times 2, the root of 4 times 2, plus 3. And we have 1 over root of 4 times 2. So root 4 times 2 is the same as 1 over 2 root of 2 plus 3. Yeah, 1 over 2 root of 2 plus 3. Again, you can rationalize this as let's continue on this part.
There's no internet connection right now because you're in airplane mode.
2 root 2 So rationalization is saying that just multiply the conjugate of the denominator to the numerator and the denominator itself. So we have 2 root 2 over 2 root 2 times 2 root 2. We have 8. Yeah, plus 3. And this will cancel that. So we have root of 2 over 4 plus 3. Or you see 3 plus 1 over 4 root of 2. This is your final answer.